All right, so at this point, you should have attempted this worksheet. So I'm given 4 times 2x plus 1 times x plus 1 times x minus 1. So the first thing I want to do is the same thing I did here in the example. I want to set each of these equal to 0. So see, I set each one equal to 0. But notice that 4 does not equal 0. 4 is not equal to 0. So I actually don't ever really need to set the constant equal to 0 because we know that unless the number is 0, it's not going to be equal to 0. And we also know that we're solving for x. So if there is just a constant, we don't set it equal to 0. So I'm going to start with these two on the end. I'm going to add 1 to both sides, very similar to the first one, the first example we did. So I get x equals 1, and here I'm subtracting 1. And remember, I'm doing the inverse operation because I need it to cancel. Positive 1 minus 1 will just leave me with x because that's 0. So I get x equals negative 1, x equals 1. So here, this is a two-step equation. First, I need to get 2x by itself. So in order to get 2x by itself, I have to start with subtracting 1 from both sides. And again, inverse operation. It was positive, so now I'm doing the opposite, otherwise known as the inverse, where I'm subtracting it. And I get 2x is equal to negative 1. And now I have 2x. Well, let's remember that there is a hidden multiplication sign in between here. Anytime you see a number in front of a variable, anytime a variable has a coefficient, like this, it is being multiplied. So really this is 2 times x. We just don't say it like that. So since it's being multiplied, what is the inverse or opposite operation of multiplication? Division. So I'm going to divide both sides here by 2. And when I divide 2x by 2 on the left, well, 2 divided by 2 is 1. So I'm left with 1x, which we usually just write as x, equals negative 1/2. You could write this as a decimal, but for graphing purposes, I prefer a fraction. But that could also be written as negative 0.5. Next one. Oh, and then you just write the zeros here. So negative 1/2, 0, negative 1, 0, and 1, 0. Next one. Again, I already set them equal to 0. This one's finished. X equals 0, boom, automatically done. The one all the way to the right is a one-step equation, so I just add 5 to both sides, and I get x equals 5. Boom, done. The middle one is, again, a two-step equation, so I have to add, because negative 2 plus 2 is 0, so that cancels. And I get 5x equals 2. Remember, anytime there is a number in front of the x, anytime x has a coefficient, that means it is being multiplied. So this is 5 times x. So since it's being multiplied, we need to divide it in order to get it away from the x, because we have to do the opposite operation. And we get x equals 2/5. So I know that I have an intercept or a 0 at 0, 0, at 2/5, 0, and at 5, 0. So finally, here's number 3. Number 3 is different from the other ones. Automatically, we should be able to see that. The first three are already in factored form. This one is not. So that means the first thing I have to do is factor it. So I can factor it in one of two ways. I can say, what are the factors of 15 that will add or subtract to give me 2? Well, it has to be 3 and 5. I can't use 1 and 15. So that would make it a negative 5 and a positive 3 to give me a negative 2. And I just break up x squared into two binomials, the product of two binomials, which means the multiplication of two binomials, where x is in each of them. You see, x here and x here will give me x squared. And then I can put positive 3 in one and negative 5 in the other. And if we were to multiply this back out, I would get 3 times negative 5 gives me negative 15, and 3x minus 5x gives me a negative 2x. So that is the more simplified way to do it. We could also do it by factoring by grouping, which I would still end up with the factors of positive 3x and negative 5x. And we would just have the extra steps of grouping in. So if I group these, I need to factor out x, and I'm left with x plus 3. And when I group these, I need to factor out a negative 5, and I'm left with x plus 3. And then finally, one more step, which is factoring out the x plus 3's. And I am left over with x minus 5 in the second binomial. I'll fix that parenthesis. Cool. So those are the two separate ways to factor it. It is totally up to you. Now that they're factored, we can see, all right, well, if I set x plus 3 equal to 0, I have to subtract 3 from both sides. Whatever you do to one side of an equation, you do to the other. And I get x equals negative 3. So one of my zeros is negative 3, 0. And based on what we kind of observed previously, we're seeing that when the coefficient on x is 1, otherwise known as x just being by itself, what we see in the parentheses, the 0 is the opposite. So I'm going to predict that this 0 is going to be 5. So let's see. X minus 5, set that equal to 0. Add 5 to both sides. And I get x equals 5.